All right, guys, so for the first part here of section 2.3, we're getting introduced to some very important rules that we're going to be using quite a bit here. So I've got all this stuff kind of pre-written in here just because I had already done this and then the video crashed, and so I'm doing it again, but I had already written these down. So let me take you through these. Feel free to pause at any point here. So the first thing we're going to be looking at is what we call the product rule. Product meaning when you're multiplying terms together. So if I had a function like this and I was going to multiply this as my first term and this is my second term, well, if we were going to multiply those together, how do we find the derivative of that? So the first thing you could do if you wanted to is you could just distribute. So I could distribute the x to the third to all of those, and then I could distribute -1 to all of those, and I could kind of go down that route and then do the power rule. But there's going to be plenty of cases where that would definitely not make sense to do or not even be possible to do. So we definitely need to learn the product rule, and in most cases it'll be the quicker route anyway. So let's take a look at what this looks like. So f of x we're calling our first term, g of x we're calling our second term. So here's what the rule looks like. So we're going to take the first term times the derivative of the second term plus the second term times the derivative of the first. Okay, and so we're simply going to follow that model as we go through this example right here. So if we wanted the derivative of this, again, I'm going to start with the first term times the derivative of the second term. So the derivative of this would just become 3x squared plus the second term times the derivative of the first, right? And the derivative of that first term, if you use your power rule, this becomes 2x to the first minus 2, and the constant goes away. So that would be the derivative of that first term. So I just laid it out within the model that you see right here. And from there, it's just kind of use your algebra to simplify. So on this one, we then did distribute the 3x squared to this. And we did some distribution here, or FOIL. Came out looking like this. So I already had the next row written in there for you, so you didn't have to write it all. But after you did some distribution, this is what it would look like. And then from here, now that we've simplified, now we're just going to combine like terms. So if you combine like terms, we always want to get it as simple as it can go, and that would be it. That would be our derivative. So that's our product rule. Let's try it on one of our trig functions here. So in this case, x is my first term, and the cosine of x is my second term. So again, going after the model of my first term times the derivative of the second, plus the second term times the derivative of the first. Right? And so just remember the basic rules, like when we came to the second step and we had to do the derivative of our second term, well, the derivative of cosine we learned was negative sine. Right? And so things like that we got to remember as we go within that process. And then just to clean it up as much as we can, this would be the best look that you see right there. So that's our product rule. Let me show you the quotient rule. So quotient rule, whenever we are dividing, the one thing you cannot do is just do the derivative of each one and then divide them, right? It doesn't work like that. So here's what the formal rule looks like, but let me take you through the really common saying that's going to help you remember what this looks like. Okay, and so this is the one on top we call the high function, the one on bottom we call the low function, right? So this is high, this is low. And so the way we remember this is low d high minus high d low over low squared, right? In other words, the bottom function times the derivative of the top minus the top function times the derivative of the bottom over the bottom squared, right? So low d high minus high d low over low squared. So here's what it would look like if we really kind of wrote it out formally within those, but this saying will really help it stick, and it kind of helps remember where everything goes. So let me take you through a couple of these guys. So look down here at example 4. So here's our top function, here's our bottom function. So again, this is the high, this is the low. So all I'm doing is the low, so low d high, derivative of the top, minus high d low, so that's the derivative of the bottom, over the low squared, over the bottom function squared. So that's just going to be our setup, and then we're just going to clean it up as much as we can. Typically we don't expand things like this. We want to keep things in factored form. We just want to simplify this as much as we can. If I could reduce, I will, but I'm just going to do some cleanup here. So distribute the 2 and distribute the negative over here. Comes out looking like this, and if you combine like terms, I'm left with just the 5 on top, and we're going to keep the bottom just as it is. So one of the things that you really need to consider moving forward is now you have options, right? So if I have a quotient, right, if I have a fraction, I could do the quotient rule on this, but the one thing we always want to consider is, well, what if I could just simplify it first and then take the derivative? I don't really want to use the quotient rule if I don't have to. It's kind of a last resort. It's only if you cannot simplify this any further and it's still a fraction, then I got to do the quotient rule. But I'd rather not. So in a case like this, and we did this earlier on, I can simply divide each of these by 2x and basically be left with no more exponent on, or no more variable on bottom, and so I won't even have to do the quotient rule. So if I divided each one of these by 2x, I'm going to get this look right here. And now I would just do the power rule and do the derivative of each term individually to come out looking like this. And that's in a case like this, that would be a whole lot simpler than trying to do the quotient rule. So always consider simplifying as much as you can first before you try doing the derivative. All right, let me take you to the second page. So just a few more examples we're going to go through on this page. Sorry, let me adjust. Okay, so here's a classic quotient rule right here. I'm looking at the cosine of x over 2e to the x. And so I'm just going to go through our quotient rule here. So again, this is low d high minus high d low over low squared. And one thing we always, so a couple things to keep in mind with derivatives. We know derivative of cosine is negative sine. The derivative of 2e to the x is simply 2e to the x, so that part was pretty simple. So that would be our setup within the quotient rule, and then we're just going to do some cleanup. What I did on this one is I actually factored out the 2e to the x as my greatest common factor, so it looks like this. And the reason we did that was simply because of what I see on bottom. I can now reduce. So I got 2 of them down here and 1 of them up here, so I knocked out 2e to the x from here and from here, and this is what I'm now left with. So that one cleaned up pretty well according to that. For example 7, we won't do a ton of these, but just so you know when you run into it, what if you had more items that were being multiplied? All right, so how do we apply a product rule when I'm multiplying 3 factors together? Okay, and so here's kind of the general layout of that. So it's like the derivative of the first times the next 2, plus now I'm doing the derivative of the middle times the other 2, plus the derivative of the third one times the other 2. Right, and so that's like the general model of what that would look like. It does come with a lot of distribution. So if you want to fill in the blanks with me here. So again, we started with the derivative of the first one. So if I took the derivative of these guys, it just becomes 2x to the first plus 2. And so that's where this one came from. These were the other 2 functions. And then in the middle here, I have the derivative of the middle term. And then on the last one, I have the derivative of the third term. Right, and so that's what that would look like. And then to clean it up, you would have to do quite a bit of distribution, combine like terms, and all that fun stuff. Right, all that basic algebra. So let me take you down to the final 2. So this one here is a real popular one. You're going to run into some of these where you're just doing the product rule, and we could do this with a quotient rule too. But instead of getting information from the functions, you're actually getting the information from graphs. And so the first thing we want to do on this is simply lay out the pattern of what this would look like according to the product rule. So if I did my first times the derivative of the second plus second times derivative of the first, so there's just the formula. And in this case, we're doing the derivative where x is 1. And so all I did in my next step was replace my x's with 1s. And so these 4 items now I need to find from the graph. So if I wanted to find f of 1, so right here's the f function. and where x equals 1, my y value is 5. And so that's where he comes from. The derivative of the g function where x is 1. So if I look at the g function, here's where x is 1. So what is the derivative or the slope at that point? Well, this is just a line. So if we consider the slope of this line, this thing is going up 2 over 1. So the slope is 2. And so because it's a line, we know the slope is constant for every point on that line. So my derivative at 1 would just be the 2, which is the slope of that line. G of 1. So now we're looking for the y coordinate, where x is 1. So this guy's at 1, 1, so we get a value of 1. And then again, the derivative or the slope of the f function, where x is 1. And so if I look at the f function, we're now saying what is the slope at this point. And again, just like the other one, this guy's a linear, so let's just identify the slope of the line. This is going down 1 over 1. So my slope is -1 at that point. And just a little simplifying here, and you come out with a 9 on that. All right, last one. So take a look at this guy. Let me talk you through. Again, you can kind of just pause and fill in, and then kind of hear the explanation if that works for you. But they're talking about the base of a triangle, and they're giving us this expression for the base. They're giving this expression for the height, and they want the rate of change, or the slope, or the derivative, same thing, of the area with respect to time. Right? So we're going to talk about the area of this triangle with respect to time. So area is like the y value, and t is the x value. So we know that the general formula for area of a triangle is 1/2 base times height. So I'm just going to take the information they gave me. This was the expression for base. That was the expression for height. And that's what we're going to work with. Obviously, they're being multiplied together. So when I go to do the derivative, I'm thinking product rule. Right? So let's do a little product rule on this. So here's just the kind of the proper notation. If I want the derivative of the area with respect to time, so a prime t, could also be written as this, dA dt. You can always take a scalar multiple and just keep it outside. And we're just going to do the product rule on those two functions that actually contain variables. So we got our first times derivative of the second plus the second times the derivative of the first. And so that's going to be our setup, just using the product rule. And technically that's it. That is our rate of change with respect to time. However, we just don't like to leave it like that, right? It's like simplifying a fraction. You always want to simplify as much as you can. Okay, and so we're just going to go through and simplify whatever we can on this. So if you kind of work your way down to here, I had multiplied terms together like this. Do keep in mind that when you're multiplying, in cases like this, remember you would add exponents. So like 1/3 plus 1 would give me the 4/3. And so don't forget your rules of exponents as you're going through. And then these guys were foiled. Over here, we're just combining like terms, just simplifying. The very last thing that I did was distribute the 1/2 to this term and to this term in order to get this look. So we do want to simplify as much as we can. This would be a much better function to work with than this would be, right? So this was our derivative. The rest was just simplifying to put it into friendlier terms. And that's it for this one.